Good morning and welcome back to math. You will notice that we are going to move on to lesson 4. We are still talking about equivalent ratios. Now remember, ratios are two numbers. Okay, so we have to remember two numbers. Equivalent ratios means that we're going to take our ratio and we have to find a positive number that we're going to multiply that ratio by to get the other ratio, and we're going to practice that today. So let's look at example 1 and see if we can find the ratios in this story. It says the morning announcement said that 2 out of every 7 sixth graders in the school have an overdue library book. Jasmine said, that would mean 24 of us have overdue books. Grace argued, no way, that is way too high. How can you determine who is right? So the first thing we have to do is we need to find the ratio in the first sentence. And the ratio in the first sentence says 2 out of every 7. And so we would write that ratio like this. Two numbers. 2 out of every 7. Then we notice that it says that would mean 24 of us have overdue library books. So we have here the number 24. So the 24 is the students that have overdue library books. So that would be our first number in our ratio. 24 out of how many students? Remember, we had here 2 out of 7 students. So this is part of the students, and this is the whole. Now we're saying 24 out of how many? So in order to see if these are equivalent ratios, we're going to take our pencil and we're going to basically make some line here to go from the 2, which is the first number in my ratio, to the 24, which is the first number in my ratio. What do I multiply 2 by to get 24? 2 times what? Well, let's see. If you look at your multiplication charts, you should know that it's 2 times 12. 2 times 12 is 24. In order to make an equivalent ratio, I have to take and multiply this times the exact same number. So this is also going to be times 12. So if I would take 7 times 12, then I would find out the total number of students. So I take here, and I take 7 times 12. I would know that the answer is it working on there so we can see that? 84. These are equivalent ratios. Why are they equivalent? Because we took the first ratio and we multiplied them both by the exact same positive number to get these answers. Okay? So we're going to call the number that we multiply down here, we're going to call that C. Okay? We're going to use, and that's called a variable, it's our letter. So we're going to say that C was 12 for both of these. 2 times 12 is 24, and 7 times 12 is 84. So let's go down here and see if we can find some more equivalent ratios. Decide whether or not each of the following pairs of ratios is equivalent. If the ratios are not equivalent, find a ratio that is equivalent to the first ratio. If the ratios are equivalent, identify the positive number, right here, C, so we're going to find out what C is, that could be used to multiply each number of the first ratio by in order to get the numbers for the second ratio. All right, so remember, just like we did up here, it kind of reminds me of Wonder Woman. It kind of looks like a W here. We're going to draw lines, and we're going to go from the first number in this ratio to the first number in the second ratio. So right here we have 6 is first and 42. So we'll go ahead and make our line here, 6 to 42. All right, well, let's think about this. What can I multiply 6 by to get 42? You're correct. In order to get 6 to 42, we have to multiply it times 7. All right, now let's take the second number and draw the line to the second number. 11. 11 times what is 88? Okay, your multiplication chart, you can look at it. 11 times 8. Oh, let's look carefully. Remember, these have to be the same number in order for my ratio to be equivalent. Are these two the same number? They are not. So these are not equivalent ratios. If I wanted to make equivalent ratios, I'm going to obviously need to change some things. So over here, let's go ahead and let's write the first ratio, 6 to 11. And let's go ahead and do 42, and let's find out what we want to put here for our second number in our ratio. So remember, once again, the first number to the first number. We already know that it has to be 6 times 7 is 42. We just solved that. Now, in order to make an equivalent ratio, we're going to take the second number here to the second. And remember, we have to multiply by the exact same number. So we have to multiply by 7 here. So 11 times 7 would be 77. Now we have equivalent ratios. We multiplied by the exact same positive number. So our new ratio, we're going to say, would be 42 to 77. All right, let's go ahead and move down to B. Let's see if these two are equivalent ratios. All right, so remember, we're going to go from the first number to the first number. All right, 0 times what is 0? And 5 times what is 20? Okay, well, this here actually could be any number I want. It could be 0 times 1. That's 0. 0 times 10 is 0. 0 times anything is always going to be 0. So this doesn't have to be 0. So we're going to leave this one blank first, and let's do the second one. Let's look at the 5. 5 times what is 20? 5 times 4. Could I put times 4 for this first one? Could I say that 0 times 4 is 0? I can. So if you notice, we have here what we call our C is exactly the same number, and so we have equivalent ratios. So we're going to say yes. Yes, the value C is, what did we multiply in order to make this true? The value C was the integer 4. Okay, let's go ahead and turn over to the next page. All right, let's look at exercise 2. In a bag of mixed walnuts and cashews, the ratio of the number of walnuts to the number of cashews is 5 to 6. So we have our first ratio right here, our first two numbers. Determine the amount of walnuts that are in the bag if there are 54 cashews. Use a tape diagram to support your work. Justify your answer by showing that the new ratio you created of the number of walnuts to the number of cashews is equivalent to 5 to 6. Okay, so we have a couple of things to do. First of all, let's go ahead and write down the ratio we have here, 5 to 6. 5 to 6. 5 stands for, well, let's reread the problem. In a bag of mixed walnuts and cashews, the ratio of the number of walnuts to the number of cashews. So we know that the first number stands for walnuts. So I'm going to kind of just make a little note right here. We have walnuts first, and then we have cashews next. Okay, we're going to want to make an equivalent ratio. Now, if you notice, we also had right here the number 54. Determine the amount of walnuts that are in the bag if there are 54 cashews. Well, remember, the first numbers are walnuts, and that's what we're determining. We want to know how many walnuts, but we know that there are 54 cashews, so we need to make sure that we put 54 second, just like it is over here. We don't want it first. Okay, and we're going to go ahead and make our Wonder Woman lines here. First number, second number to second number. Okay, well, we can't find out what we're multiplying by here because we don't know the answer yet. We don't have the integer for this ratio, but we can solve the second one 6 times what is 54? Well, 6 times, hopefully you know your multiplication facts, 6 times 9. In order for this to be an equivalent ratio, this also has to be times 9. So now we have 5 times 9, and most of us know that 5 times 9 is 45. So right now we have 5 to 6. We found that the equivalent ratio is 45 to 54. Well, if you read or listening to the directions, it says that they also want us to go ahead and make what we would call a tape diagram. So we're going to kind of just move down here a little bit, and we're going to go ahead and label walnuts, and then we'll label cashews. Okay. Remember, the original ratio we started with was 5 to 6. 5 for the walnuts and 6 for the cashews. So let's go ahead and make here for the walnuts 5 boxes. And then the cashews we have to make 6. Okay, so we have our 5 to 6. Now if you remember, we originally found out that there were 54 cashews. So we knew that the cashews was equal to 54. How did I know that? Because it was listed right up here in my story problem. Now if I take 54 and I divide it into 1, 2, 3, 4, 5, 6 boxes, let's go ahead and check. 54 divided into 6 boxes was 9. So we would put 9 in all of these boxes. 9 matched our C here, didn't it? All right, remember, if this is 9, then these boxes as well have to be 9. And 1, 2, 3, 4, 5. So now we have 9 5 times, and 9 times 5 is 45. So we have the same number here. We've proved it with our tape diagram, and we have shown up here our equivalent ratio. Okay, so let's go ahead and flip over here to our problem set. And let's just do a little bit more practice here. So problem number 1 says, use diagrams or the description of equivalent ratios to show that the ratios 2 to 3, 4 to 6, and 8 to 12 are equivalent. All right, so remember, we can do one of two things. We could either do what I call the Wonder Woman, or we could do tape diagrams. Let's go ahead and start here first with 2 to 3 and 4 to 6. Are these two equivalent ratios? Well, let's see if we can do. Let's make the first line to the, we'll connect the first number to the first number. 2 times what is 4? 2 times 2. Let's do the second number and the ratio to the second number. All right, 3 times 2 is 6. So we found out that these two are equivalent. We have one more though. We have 8 to 12. So if we already know that these two are equal, let's go ahead, let's do 2 to 3. Let's put 2 to 3 and let's see if it is equivalent to 8 to 12. So go ahead and see if you can figure out what we're going to multiply by here. Remember, we're going to make a line from the first number in this ratio to the first number in that ratio, and the second number. And the second number kind of looks like a W here. 2 times 4 is 8. 3 times 4 is 12. So we found out that they are equivalent ratios. Okay, well, we're going to go ahead and make a tape diagram as well. Let's go ahead and make 2 and 3. So we'll go ahead and make 2 and 3. Now, is there a way to make 2 to 3 equal to 4 to 6? Well, if I took 4 and I had to divide it into 2 boxes, most of us already know what's 4 divided by 2. It's 2. So if I put 2 in here, 2 plus 2 is 4. If I put all the 2's down here, 2, 4, this worked. All right, well, let's keep our 2 to 3 one more time. 2 to to 3. This time, instead of it being equal to 4 to 6, we want to see if it equals 8 to 12. Is it possible to take 8 and divide it into 2 boxes? It is. We would put a 4. Remember, if this is 4, well, then that means down here has to be 4 as well. 4 and 4 is 8, and 4 plus 4 plus 4 equals 12. So we've proved that all of these 2 and this one, they are equivalent ratios. We proved it here by what I call the Wonder Woman style, and we proved it down here by using tape diagrams. Okay? All right, so quick lesson. When you're finished, you can go ahead and fill in your Google form, and I will see you all tomorrow for math.